Hi, my name is Danielle Curry, and I'm a sophomore majoring in civil engineering at North Carolina State University. Today, I'm going to talk about the research I have been doing through the University Honors Program on sustainable development over the last 2 semesters. In the fall semester, I took a class called CE 297, which focused on sustainable infrastructure. Throughout the semester, I learned about sustainability, quantifying environmental impacts, and engineering economics. The goal of my project was to utilize the skills I learned in CE 297 to learn more about sustainable infrastructure. For the first part of my research, I wanted to learn more about sustainable development and sustainable development on NC State's campus. So what is sustainable development? The United Nations Brundtland Commission defines sustainable development as the kind of development that meets the needs of the present without compromising the ability of future generations to meet their own needs. At NC State, the Sustainability Office was established in 2008 with the mission of equipping the NC State community for a leaner, smarter, stronger future. The Sustainability Office has worked to promote sustainability on campus in a wide variety of areas. In 2017, the university released its 5-year sustainability strategic plan. One of the main focuses on campus is making campus infrastructure more sustainable. For example, the university has pledged that all new construction over 20,000 square feet will be at least LEED Silver certified. Here are a few examples of sustainable development on campus. First are the Wolfridge Apartments. These apartments on Centennial Campus house over 1,000 residents and are all LEED Silver certified. Additionally, in the complex there is a 55,000-gallon cistern that collects rainwater from the roofs to water plants on campus. Also, on Centennial Campus, there is the Soul Garden. The Soul Garden is a student-run community garden that uses sustainable practices such as composting. The second part of my research focused on industrial symbiosis and eco-industrial parks. In the past year, a group purchased a plot of land in Hurt, Virginia. The land was previously home to a factory that has since gone out of business. On the site, there's a lot of water access and railway access, making it a good location for an industrial park. They reached out to the College of Design to help establish the best use for the property. Along with professors in the Department of Civil, Environmental, and Construction Engineering, they are working to establish an eco-industrial park. The goal of the project is to create an eco-industrial park with industrial symbiotic relationships. The project also has a significant academic side to learn how to establish eco-industrial parks and industrial symbiosis. So what is industrial symbiosis? Industrial symbiosis stems from the idea that the waste of one process can be reused in another process. Industrial symbiosis engages traditionally separate entities in a collective approach to competitive advantage, involving physical exchange of materials, energy, water, and byproducts. For example, say we have a factory that creates a lot of wastewater and another factory that needs water for cooling. By connecting the two factories in an industrial symbiotic relationship, we can save materials, energy, and money. The concept of industrial symbiosis was first fully recognized in an industrial park in Kalundborg, Denmark. The partnership started forming in the 1970s in response to environmental regulations raising the cost of waste disposal. Some of the partnerships also formed to lessen the cost of purchasing raw materials. The Eco-Industrial Park in Kalundborg has been the focus of most industrial symbiosis research. It serves as an example of how beneficial industrial symbiosis can be and has been used as an example to help create further eco-industrial parks. On the left, you can see an example of the processes and the exchanges in Kalundborg. The exchanges in Kalundborg center around 5 main partnering units. These units are a power plant, oil refinery, plasterboard producer, biotech/pharmaceutical producer, and the local municipality. Some of the main material exchanges are wastewater and cooling water, sludge to fertilizer, fly ash to cement, waste heat to district heating, and gypsum to particle board. The results of the exchanges speak for the benefits of industrial symbiosis. Water consumption has been reduced by 25%, 5,000 homes receive district heat, and approximately 2.9 million tons of waste are exchanged each year. My individual research focused on the academic side of the project. The goal of my research was to understand how industrial symbiosis has been studied and created. To do this, I reviewed previous studies on industrial symbiosis and researched how industrial waste has been quantified in order to establish exchanges. First, I looked into how industrial waste has been quantified to form industrial symbiosis connections. In the late 1990s and early 2000s, there is a large interest in industrial symbiosis and waste quantification. One of the first studies I looked into was the Triangle J Council of Governments report. In 1997 through 1999, a project was undertaken by the Triangle J Council of Governments with researchers from NC State, Duke, and the University of North Carolina at Chapel Hill. The Triangle J Council of Governments is the governing body for Research Triangle Park in North Carolina. The goal of the study was to identify possible industrial symbiotic relationships within Research Triangle Park. The researchers collected data from 182 industries and identified partnerships that could save hundreds of thousands of dollars a year. To establish possible connections, the researchers sent surveys to industry partners. They identified the materials that could most likely be exchanged and included these in the survey. They also interviewed many of the companies in person. After collecting the data, they identified possible exchanges and reviewed the environmental and economic impacts of the exchange. The researchers then helped set up meetings with the companies to create the exchange. On the left, you can see some of the most likely to be exchanged materials they identified. Next, I looked into the academic works by Robert and Leslie Ayres. Robert Ayres is known for being one of the pioneers of industrial ecology. Industrial ecology is the study of industrial processes with the goal of making them more sustainable. Robert and Leslie Ayres have written numerous books on sustainability and industrial ecology. They are known for their industrial metabolism approach to quantify waste. Industrial metabolism is a way to understand the flows of materials through a system. The approach views industries as a part of a much larger system instead of industrial entities. The industrial metabolism approach is based off the law of conservation of mass. On the slide, you can see diagrams showing the industrial metabolism approach. A simple example of the industrial metabolism approach would be the process of making a peanut butter and jelly sandwich. Using the industrial metabolism approach, first I would look at the inputs I would need to make the sandwich, such as bread, peanut butter, and jelly. I would also consider the materials needed to make the sandwich, such as a plate and knife. I would numerically quantify these inputs, such as 2 pieces of bread, 1 tablespoon of peanut butter, and 1 tablespoon of jelly. In my process, I would also take into account the environmental impacts that occurred to get these inputs. Next, I would quantify what happened to the inputs after they went through the process. I would measure how much energy and waste was produced, where they were going, and the environmental impact of those outputs. Then I would compare the amounts of inputs and outputs to see if they meet the law of conservation of mass. For industrial processes, this approach is much more complex. However, it allows for the entire impact of the process to be assessed. The next study I reviewed was Accounting for Non-Hazardous Industrial Waste by Jonathan Krohns. In his dissertation, Krohns argues for a new triangular approach to quantify industrial waste. In the triangulation approach, Krohns uses 3 methods to quantify waste to help ensure the accuracy of the calculations. He uses the materials balance approach, or industrial metabolism approach, upscaling, and historical forecasting. In the upscaling step, he looks at available data on waste for a region and scales it to consider a larger region. In the historical forecasting, he scales previous quantifications to meet present-day sizes. Krohns argues that this method helps prevent error. After studying case studies on quantifying waste, I shifted my research to focus on finding databases. I looked for available databases of waste streams to help predict possible connections between industries. My goal was to find numerical data on the amounts of waste created by various industrial processes. By having numerical amounts, the waste could then be quantified to help establish connections. While my previous research identified methods of quantifying processes, the process of getting the data to perform those calculations can be very difficult. Waste can take many different forms, which can be hard to compare. Additionally, production processes can vary within firms of the same industry. Some companies are also afraid of revealing company secrets. They will not reveal their entire process. Waste measurements can also be expensive. However, due to the high cost of waste disposal, many companies are interested in methods to reduce the amount of waste they send to landfills or treatment plants. Also, while the production process can vary, the main materials and processes within industries are often similar enough that predictions can be made. When searching for databases, one industry stood out among the rest. The paper industry had the most complete waste data available. The National Council for Air and Stream Improvement started surveying paper and pulp facilities to understand the amount of waste being created by the paper industry as a whole. The study was started because in the early to mid-1900s, the production process for paper often created a large amount of waste that was often hazardous or hard to dispose of. The survey typically gets responses from 70% of the paper industry. The additional 30% can be estimated. Besides the paper industry, I was not able to find another industry that regularly collects or quantifies their waste as a whole. However, there exists census data regarding imports and exports and the usage of natural resources for industries that are directly reliant on natural resources. Life cycle inventories also quantify the environmental impact of processes. While I did not find as much numerical data on production processes as I had hoped, I was able to find a large source on the production processes. The EPA Notebook Sector Project was a project initiated by the Office of Compliance within the Office of Enforcement and Compliance Assurance in the EPA. The project produced notebooks for common industries and processes. The book provides common sense environmental protection measures and data for industries. Each notebook contains general industry information, descriptions of the industrial processes, pollution outputs, pollution prevention opportunities, and federal regulations. These notebooks are an extremely valuable source because for each process they list the inputs, outputs, and a detailed description of the process. In the sections on pollution prevention, the notebooks often contain reuses for the output waste, which are often industrial symbiosis connections. From my research, I was able to reach a few conclusions. First, industrial ecology is a continually growing field. In the late 1990s and early 2000s, there were a lot of academic works produced studying industrial symbiosis. These works can be used to establish industrial symbiosis today. For example, these works can be used to guide the creation of an eco-industrial park in Hurt, Virginia. By looking at past works, we can learn the best approach to establish connections. When it comes to waste quantification, there are many different methods such as the mass balance or industrial metabolism approach, historical forecasting, and upscaling. The available data for performing these calculations varies by industry, with the paper industry having the most available data. However, census data and other government reports can be used to estimate the amounts of waste created. Lastly, there's a lot of future work that can be done on studying industrial symbiosis and establishing an eco-industrial park in Hurt, Virginia. More research can be performed to find or create a database with numerical data about the processes of common industries. This data, combined with the quantification models, can be used to design future eco-industrial parks with industrial symbiosis.